Hey, good morning, people. Good morning to my dear friends. See, today we are going to start with the questions on binomial distribution. Okay. First, we will start with a few classic problems and then we will go deep down into understanding the main core idea of binomial distribution. Okay, so let me start with the first question. Yes, look at here. What is this question saying? This is a classic coin toss problem. The problem says 10 coins are tossed simultaneously, and you need to find the problem that is the probability of at least 7 heads. So, basically, you need to imagine like 10 coins flying up, spinning, and they land. Okay, we want the chances of getting 7 heads, 8 heads, 9 heads, or even all 10 heads. Okay, this is a perfect example of a binomial experiment. Like, let me break down why binomial. Binomial just means there are two outcomes, right? Heads or tails. And see here, the probability of getting a head on any single coin is always half, and each coin is independent of the others. So, you need to do first is you need to make a random variable. You need to define a random variable. We will call it x, and let x be the number of heads we get. Since there are 10 coins and the probability of success, which is a head, is half, we can say that x follows binomial 10 comma 1 by 2. Now, this basically means this is the definition of the binomial distribution. Okay, this line x follows binomial 10 comma half. Now, the question asks for the probability of at least 7 heads. In math terms, that is basically probability of x greater than equals to 7. And what is greater than equals to 7? That is just what I said at first, which is probability of x equals to 7 plus probability of x equals to 8, and it goes on till probability of x equals to 10. Okay, so you see that. Now we will plug into the formula. What is the formula for PMF of binomial distribution? Look at here. Probability of capital X equals to small x is equals to n chooses x, p to the power x, q to the power n minus x. Now, here n chooses x is the choose function, and p is the probability of success, and q is the probability of failure. Okay, which is 1 minus p. Now, since p and q both are half here, the calculation will be a bit cleaner. Okay, now let's see how. You need to find first probability of x equals to 7. And how do you write it? 10 chooses 7 into 1 by 2 to the power 7 into 1 by 2 to the power 3. And likewise, you will write for x equals to 8, you will write 10 chooses 8 into 1 by 2 to the power 8 into 1 by 2 to the power 2, and so on. But to save time, you will have calculators in your exam halls also. So you can just calculate it and you will get the answer to be 0.171, right? 0.171. So that means there's about 17% chance of getting 7 or more heads. Not super likely, but definitely possible. And this is problem number 1. Now I'm zooming in a bit for problem number 2. Look at the problem number 2. What is this problem saying? See, this one is a fun problem, okay? It's about a person who claims they can identify a specific type of wine in a glass. Let's read it. What is the problem saying? The problem saying is a person claims he can identify a particular wine when he is given 6 glasses. Let me come to the next part. Look at here that there are 6 classes, okay, and he correctly identifies at least 5 of them. We need to find the probability of his claim being first accepted, next is rejected, okay, and we are told to assume that the claim is true. We are assuming that the claim is true, okay. So that means if he is really an expert, his probability of getting a single glass right is 0.75 or 75%. All right, let us first define our random variable. Let x be the number of classes he correctly identifies. Okay, so what is the number of trials here? It is n is equals to 6, right? Because there are 6 classes. And what is the probability of success? P is equals to 0.75. Since we are assuming that the claim is true, right? And then comes the probability of failure, which is Q is equals to 1 minus P, which is equals to 1 minus 0.75, which is equals to 0.25. Okay, so we have a binomial distribution. X follows binomial 6 comma 0.75. Now see, the claim is accepted if he gets at least 5 right. So we want what? Probability of x greater than equals to 5, and that is the probability of him getting 5 right or 6 right. Okay, so here see what I have written. Probability of x greater than equals to 5 is equals to probability of x equals to 5 plus probability of x equals to 6. And then next what you need to do, you need to plug into the formula of the binomial distribution. We already know the PMF, which is n chooses x, p to the power x, q to the power n minus x. For x equals to 5, what will be the value? It will be, let me scroll it up. Yes, 6 chooses 5 into 0.75 to the power 5 into 0.25 to the power 1. And for x equals to 6, it will be what? 6 chooses 6, 0.75 to the power 6, 0.25 to the power 0. Okay. Now, if you calculate this step by step, you get the answer. See here, 0.46, no, 0.533. Okay. So basically, what does this mean? This 0.533 means that the probability that his claim is accepted is about 53.3%. Okay. Now, for part 2, that is the probability that the claim is rejected, what you need to do? If it is not accepted, it will be rejected, right? And since the total probability of everything happening has to add up to 1, we can just subtract from 1. Okay, so 1 minus 0.533 is equals to 1 minus 0.533 is equals to 0.467. So that is the chance they tell him he's wrong. Okay, even though his claim is true, a 46.7% chance of a false negative is there. Okay, now we will come to the next question. See, our last problem of this situation type is this one. Okay, this question states that a probability of a man hitting a target is 1 by 4. If he fires 7 times, what is the probability of him hitting the target at least twice? All right. First, you need to do what? First, you need to define the x, which is the random variable. Okay. Let's define x as the number of times the man hits the target. Then, what is its hit probability? Hit probability is 1 by 4, as we have been given here. And what is the miss probability? It is the q, which is 1 minus 1 by 4, which is equals to 3 by 4. And what is the number of trials here? N is equals to 7. Okay, so x not belongs, x is follows binomial 7 comma 1 by 4. And we want what? Probability of x greater than equals to 2. Now at least 2 means 2, 3, 4, 5, 6, or 7. That is a lot of terms to add up. Okay, but here's a pro tip. It's almost easier to use the complement rule in these type of questions. Look at here what I've written. Probability of at least 2 means is equals to 1 minus probability less than 2. Less than 2 means what? Means 0 hits or 1 hit. That is the only two probabilities to calculate. Okay. So basically here you need to write probability of x greater than equals to 2 is equals to 1 minus probability of x equals to 0 plus probability of x equals to 1. And next you need to plug into the formula, like 7 chooses 0 into 1 by 4 to the power 0 into 3 by 4 to the power 7. Okay, and the next for x equals to 1, you need to write 7 chooses 1 into 1 by 4 to the power 1 into 3 by 4 to the power 6. Okay, now look at here. What is the answer we get? By all these steps, you get the answer 0.5575. So what does this mean? This means that he has about a 55.7% chance, okay, of hitting the target at least twice. Now, there's a key takeaway from here, because even though his aim isn't that great, like because you have got 4 shots and he could hit only one, since from the probability we already got, right? Like the what was the hit probability? It is 1 by 4, right? But here, which is basically 25% shot. And here, for over 7 shots, he is getting 55.7% chance of hitting the target at least twice. That is a solid strategy, right? So, from this question, you can understand if you increase your number of trials, your probability of getting success will increase, right? Now, coming to the next question. See, before we wrap up, I want to quickly show you two more short but super important problems, okay? That test your understanding of the rules of binomial distribution. First, look at this question. This is the invalid statement problem. Someone says the mean of a binomial distribution is 3 and the variance given here is 4. Is that possible? We know that mean is equals to NP, which is equals to 3 given here, and variance is NPQ. So if we divide the variance by the mean, we get Q, right? NPQ by NP is equals to Q. So Q is equals to here 4 by 3. But that means Q is equals to like 1.333, right? But Q is a probability. It must be between 0 and 1. It can never be greater than 1. So this statement is invalid. You need to always check the parameters. Okay. From this question, we get this takeaway that for every question, you need to check the parameters. Next, we come to the next question here. Look at this next question. This question says, first read the question. This question says the mean and variance of a binomial distribution are 4 and 4 by 3 respectively. And you need to find probability of x greater than equals to 1. How will you find it? See, here also likewise you need to solve it by the formulas we already know, which is equals to NP is equals to the mean, right? So mean is given here as 4. NPQ, which is the variance, is given as 4 by 3. And if you divide NPQ by NP, you again get the Q, which is equals to 1 by 3. So the probability of failure is 1 by 3. Therefore, the probability of success will be what? P is equals to 1 minus 1 by 3, which is equals to 2 by 3. Now plug P back into the mean formula, which is n into 2 by 3 is equals to 4. So basically n is equals to 4 into 3 by 2 is equals to 6, right? Now we have got n is equals to 6 and p is equals to 2 by 3. That is great because now we want probability of x greater than equals to 1. Here again, you need to use this complement method. Okay, this complement method shows you that one probability of x greater than equals to 1 is equals to 1 minus probability of x less than 1, which is equals to 1 minus probability of x equals to 0. And if you plug into the formula, which is 6 2 is 0 into what is there, 2 by 3 to the power 0 and into 1 by 3 to the power 6, you get the answer 0.999. Okay, so basically this means that there is about 99.9% chance that the person gets more than one success. And yes, this is the last question of today, and there you have it. From coin tosses to wine tasting to sharp shooting, we have conquered the binomial distribution. Remember, the key is to define your variables, understand if you need the exact probability or the complement, okay? And always check if your probabilities make sense. So, if you find this video helpful, smash that like button, subscribe for more statistics and mathematics breakdowns, and let me know in the comments if you need any help, okay? And I have already pinned down the my handwritten notes in my blogger account. It is in the same page of random variable sem2. And if you still have got doubts, you can directly text me in my Insta account, or you can drop your comments in the comment box. Okay, so thank you for watching and see you soon in the next video. Bye bye.